Okay, guys, picking right up where we left off, I'm sorry to have to have ended one of the videos right in the middle of an example, but this example was pretty long. So, we left off, we were looking at where does 4 belong, and what remains exceeds 2/3 of 57 by 4. Now, when we say exceeds, we mean it can be greater or less, right? Exceeds means greater, always. So we're going to get rid of that less. And so we're also going to get rid of the less than symbol. Okay. So 57 minus x is bigger because 57 minus x exceeds 2/3 of 57 by 4. That means that 57 minus x is 4 more than 2/3 of 57. This is where we get into really heady, kind of difficult problems. So pay attention to this. We know that 57 minus x is bigger than 2/3 times 57 by 4. What would make the two numbers equal? We either have to subtract 4 from 57 minus x or add 4 to 2/3 times 57. Now, if x is the fraction of 57, then we could write 57 minus x in parentheses, because we do that first, minus 4 equals 2/3 times 57. Let me try that again. Equals 2/3 times 57, or we could do 57 minus x equals 2/3 times 57 plus 4. So we could do the plus 4 on this side of the equation, or we could do the minus 4 on this side of the equation. Remember, your equal sign always separates the sides of your equation. Okay? Both transcriptions are correct because both express the written statement accurately. Consider this transcription. 57 minus x minus 2/3 times 57 equals 4. Is it accurate? Is it an accurate transcription of the information written? Yes, because 57 minus x is bigger than 2/3 times 57 by 4. That means that the difference between the two numbers is 4. If we subtract the smaller number from the bigger number, we have a difference of 4. Excuse me. And that is what this version of the transcription shows. Sorry, like I said, I'm dealing with my allergies right now. Please forgive me. Okay, example 4. We want to express the following statement using symbolic language. The sum, remember sum means the answer that you get when you add, of 3 consecutive integers are numbers basically, is 372. Do the first step. Let x be the first integer. So the first integer of the 3 integers is x. If we let x represent the first integer, what do we need to do to get the next consecutive integer? If x is the first integer, we add 1 to x. X plus 1 to get the next integer. In symbols, the next integer would be x plus 1. What do we need to show to get this at the next consecutive integer? We need to add 1 to that integer, or x plus 1 plus 1. This is the same as x plus 2. Now, express the statement. The sum of consecutive integers is 372. So x plus 1 plus x plus 2 is 372. You may also rewrite the above equation as 3x plus 3 equals 372. That's combining like terms. Okay. Example 5, we're moving right along. We're almost done. So, we want to express the following statement using symbolic language. The sum of 3 consecutive odd integers is 93. Odd, not even, remember that. So do the first step. Let x be the first odd integer. If we let x represent the first odd integer, what do we need to do to the next one? If x is the first odd integer, we add 2 to x to get the next odd integer. Remember, because it's not even, it's odd, so you're jumping up 2. So that you go 1, 3, right? So it's every other one. In symbols, the next odd integer would be x plus 2. We need to add 2 to that odd integer, or x plus 2 plus 2. This could also be x plus 4. Now, express the statement, the sum of 3 consecutive integers, is 93. X plus 2 plus x plus 4 equals 93. Represent the statement in another way. So, you could write x plus x plus x plus 6 equals 93. And that's the same as writing this, because the associative and the commutative properties of addition were applied. Those properties do not change the value of the expression. Okay, so here's the exercises. Pause the video if you want to take a look at the answers and study them. We're going to go ahead and move on. This is the final piece of the exercise. Remember, don't just write these down. I'm not grading these. I want you guys to actually use these and study them. If you have problems, the first place that you need to go is these exercises and try to figure them out doing the exercises. Then I'll help you. But I want you to try to figure it out yourself, because if you figure it out on your own, it will stick in your mind better than if I tell you. Okay. So we know how to write mathematical statements using symbolic language. Written mathematical statements can be represented as one correct symbolic statement, or more than one correct symbolic statement. We must always begin writing a symbolic statement by defining our symbols or variables. The variables are usually the word we use for symbols. So x is a variable, y is a variable. Complicated statements should be broken into parts or attempted with simple numbers to make the representation in symbolic notation easier. If math seems big and hard, break it up. Make it smaller. This is what I had to learn to do to get through math. Math is something that has always been very, very tough for me. And what I have to do is I have to take my time and I have to break it up. Don't let the time scare you. Break up the problem to do it right. Okay. Have an awesome day, you guys. The problem set is due on Thursday. Have a good night.